Combining like terms can also be seen when we're solving equations. Sometimes regular numbers we use inverse operation with in equations, but these terms with variables in them can also be combined using some of the same skills when solving these equations. So when solving them, we still need to use our same grouping symbols, combining like terms, things that are the same. But remember that this idea of inverse operation needs to happen when we're going across the equal sign from one side to the other. So let's take a look at a few examples of how combining like terms relates to these equations. So first of all, let's just focus for a second. Forget about equals 20 for now. 3x plus 7x. Well, let's just focus on that one part, in other words. So we have 3x and a positive 7x, because they're both just regular x's, no exponents, we have 10x. And we can bring down this equals 20 idea as well. So 10x equals 20. But we're still trying to get x by itself. What does x equal? So now inverse operation happens. So we need to divide by this 10. X is being multiplied by 10, so we want to divide by 10 to cancel it out. But whatever we do on one side, we have to do to the other. So in this case, the x's alone, we bring that down. The equal sign, we bring that down. And then what is 20 divided by 10? X should equal 2. Okay? So it all started with this idea of combining like terms. Our regular x value, 3x plus 7x, is 10x. So there's where the combining like term part comes into the equation. Another example here, combining like terms. Well, frankly, we have a negative 2. And we have a positive 23, so regular numbers are still terms. We still need to combine them. But when we go across that equal sign, remember to use that inverse operation. So instead of minus 2, we add 2, we plus 2 in other words, and that cancels out to be 0. But whatever we do on one side, we do to the other side. So 23 plus 2 is 25, and we actually have to bring down the rest on the left side here. We didn't do anything with that 5x. The equal sign just comes down. And now there's one final step. How do we get x by itself? It's being multiplied by 5. So opposite of that, inverse of that, we need to divide by 5. So we're going to be left with x equals, and we have to divide by 5 on the other side as well. So 25 divided by 5 is 5. So x equals 5 there. One last example, if you still need another one, combining like terms. Look for your regular m's. So we have a 4m on the left side of this equal sign. We have a 6m on the other. Here's where I recommend you move the lower of the two terms that you circled. So between the 4 and the 6, the 4 is lower. It's a positive 4m. So let's subtract 4m. If you have $4 and I ask you to give me $4, you have $0 left over. So that's the idea of inverse operation. To move it, we subtract 4 on both sides, the 4m. So now we're going to bring down, instead of bringing down the plus sign, we can just write a positive 20 there. That's what the plus stands for, positive 20, equals, and 6m minus 4m equals 2m. So there's the new piece of the combining like terms. The second step is getting m by itself. It's being multiplied by 2, so we need to divide by 2, and they cancel out. So then we'll have m on the right this time, bring down our equal sign. 20 divided by 2 as well equals 10. So our final example here, m is going to equal 10.